Well, thank you for being here, and thank you for inviting me to the Technion. So I'm going to continue in the line of speakers who thank Mike Franklin for defining big data in the morning. He's been doing this for quite a bit of time, so he almost got it right. Today, this talk is going to be about he hasn't finished his coffee yet, so he's not here. I can say whatever I want. This is going to YouTube after this, so I need to be careful. So I'm going to be talking about a slightly different kind of big data than what you saw from Mike. And this is what it is. So since the beginning of the World Wide Web, it's always been about documents. But in the last 2 or 3 years, there's been a major shift, a major revolution in web search. You're now getting data out of a database. Okay, so as database people, we see everything through database glasses, right? We were asking from the very beginning, why can't web search engines just look up in a database? If they would listen to us, we wouldn't have web search today. But as of about 2 or 3 years ago, the major search engines have realized that there are a lot of the queries that are being posed by users are about specific entities or properties of these entities. And a much more effective answer for the user is something that comes out of a database. So today, if you query for Woody Allen, you get this thing here, which is called a knowledge card. Okay, and it's got a bunch of nice pictures and some information about some of the attributes of Woody Allen. This is coming out of a database. Okay, and it's even more sophisticated than that. It will give you sets of things. So it will tell you things like some of the movies that Woody Allen directed or acted in, and it'll also tell you people that are related to Woody Allen. People who look for or search for Woody Allen are also interested in these other individuals. And not only that, it will try to give you an explanation. It'll tell you why Penelope Cruz was put up here. It'll tell you because, what was it, she directed, Woody Allen directed, and Penelope Cruz appeared in this particular movie. That's why they're connected. So not only are you getting structured answers, you're also getting the derivation of the query that led to some of the other results that you're seeing on this page. Okay? Now this is unimaginable for database people who've been frustrated for a decade or more than a decade when everything on the web was information retrieval. And notice, by the way, that this is not just hidden in the bottom of the page. This is like on the top, on the right, where we used to put ads. Okay, this is good. I mean, this is really good. Okay, and our revenues didn't exactly go down either. You can even ask for sets of stuff. Okay, so you can ask for Woody Allen movies. Now you're not asking for an entity, you're asking for a set of entities, and the search engine is trying to recognize that you just did that. You can also ask for what's called association queries. You can say, who is the wife of Barack Obama? So it'll identify that you're asking about Barack Obama, but then that you're asking not about Obama himself, but about his wife, and you'll get the knowledge card for Michelle Obama. Okay, so these are very simple database queries, no joins, okay, but you're actually getting all these results out of a structured database. And if you didn't think that was cool enough, then this should be cool. So if on Google Play, when you're watching a movie, okay, suppose you now need to run and get a cup of coffee, so you pause the movie. So what do you get? You get a card out of the database. So it'll stop, and it'll show you this guy, and it'll show you a knowledge card. So in the middle of the movie, since you're off to get a knowledge card, to get a cup of coffee, the people who are staying in front of the TV will now see some structured data. Okay, that's how cool it gets. And this is everywhere. This is starting to appear in web search in many places and forms. So what does this mean? So first of all, this is backed by a very large-scale knowledge base. Okay, this is a knowledge base not about a particular domain. It's a knowledge base about thousands of domains. Okay, and it's incorporated into a search engine. So the search engine looks at the query and says, can I answer this from a database, or can I interpret this query in a way that I can answer this from a database? And if it does, then it'll put that structured result right alongside the web results. Okay, so we're not doing away with the web results, obviously, but now the search engine is asking more questions. So this is also based on, you have to build these knowledge bases. Okay, you can't just hope that they will come from somewhere. So this is also based on large-scale extraction from the web. There are multiple efforts using various information extraction techniques that go on the web, and they try to find additional facts to put in this knowledge base. And again, the main point here is it's not a knowledge base about a particular domain like books or actors. It's a knowledge base about thousands of different properties. Okay? We have to keep this knowledge base extremely correct. Okay? Because if Google gets it wrong, that's not a good thing for us. Okay? Even when we get it right, if it's very sensitive, we try not to say it. Okay? So the precision numbers that are required for this knowledge base are way above 90% correct. Okay? Now you can ask, maybe there are ways of using knowledge in web search that don't require the knowledge to be over 90-something% correct, and I'll touch on that later. There's also no controversial data. Okay, so if you ask how many nuclear weapons does Iran have, somebody might know, but we're not going to put it up there. Okay, because there are going to be multiple opinions about this, and we're not going to say, well, here are 3 different opinions, go choose your own. We stay, for now, when we put up a fact, there's general agreement about the fact. And of course, you need to keep this knowledge base correct, up to date. So the world is changing, you need to keep your knowledge base correct. So this is a huge effort in knowledge extraction, in database extraction, correctness, and everything we love to do as database people. Okay? So this is one huge trend going on that is quite significantly affecting web search companies in ways that are pretty dramatic. But then there's this other thing going on that Mike Franklin talked about. There's this, and finally he's here because he's gotten his coffee. I threw a bunch of jokes at you, but I'll have to tell you later. Okay. So there's this thing going on. It's even in the New York Times. It's about big data. And the interesting thing to me about big data is that it's not just about companies using data, whether it's created by the public or by their Internet of Things, in order to help you. This is data that is being used for social good. Okay, they're being used to do city planning. They're being used in order to improve coffee growing, to find places in the world where there's not enough clean water for people. It's used to help people during crisis response. You'll see examples of that in a moment, during the Japan earthquake or during the annual disaster on the East Coast when they have their hurricanes. Thank you. See, I'm on the West Coast. I don't exactly know how to talk. But people are even talking about data philanthropy. That now, since companies are collecting so much data, they should be donating data for the good of society, with the idea that once you put a lot of data sets together, coming from different angles, you can actually do much more interesting things. And you'll see an example of that in a moment. Here's an example of a use of Google Fusion Tables, which is a tool I'll talk about in a few moments here. This is from a couple of years ago when WikiLeaks got some data from the American military. Okay, so the American military is not very good at keeping its data secure, but when it does leak out data, the data is very well curated. So every point has a very accurate lat long about where something happened. So it's high quality data. It's just not very secure. So this is what's his name? Simon Rogers from The Guardian, one of the big newspapers in the UK. He took all that data and put it on a map and showed basically this info box. This takes a very little while to do. But this is data that was brought out to the public and was made very accessible to people all over the world. So this, for example, even over a weekend, this map got something like 100 million views per day after it came out. Everybody wanted to know some of this data. Okay, here's another example, which is crowdsourcing. We were just heard from Tova about crowdsourcing this morning. So this is the most important kind of crowdsourcing. This is where are there potholes. Okay, so if you ever lived in New Jersey, you know exactly what a pothole is. It's after, in the end of the winter, you drive and all of a sudden there's a hole in the road, and after that your car is broken. So this is somebody wrote an application where you can crowdsource potholes in Spain. This went to other areas of the world as well. But here the idea is you drive and instead of cursing, you press on your iPhone at that point. It gives you the lat long, and now the authorities know that there is a batches. Okay, so, but this is again a new kind of data collection. So this is a big day on big data. So what kind of big data is this? It doesn't exactly, I'm sorry, Mike, it doesn't exactly fit into your definition, though it's a nice extension to it. Okay, so the size of data is obviously one of the important aspects of big data. But here we're talking about other dimensions of this data that makes it very, very big. Okay, so first of all, what you're going to see is there are a lot of small data sets, but there are millions of small data sets. Does that count as big data? Thank you. I think so. So instead of having small number of very large data sets, we have millions or tens of millions or hundreds of millions of small data sets. Each one of them is valuable in a different way. Okay? The other interesting thing about this is that there are a lot of people creating this data. So usually creation of data was either done by a program collecting a bunch of actions or by very highly skilled and highly paid individuals called something with database in their title that would collect data. Today, people who are actually interested in a particular domain like coffee or journalism or crime or potholes, they are collecting data, and that data is being made available to a lot of people. And of course, the most important thing is that billions of people are actually benefiting from this data. Okay, so again, unlike usual data applications that are visible to a bunch of analysts and companies, here you have millions of people a day, or billions, well, billions, that's a bit of a stretch, but tens and hundreds of millions of people a day seeing the results of structured data. Okay, and that's a very different mode of operation. So what I'm going to be talking today is, since it's after lunch, I will be, for the most part, asking questions. Okay, so we can discuss for later, and I will. So I'll touch on some of the challenges that come about when you're dealing with these kinds of data sets, and in particular, what do we as database people do in order to enable this this data revolution? Okay, so one thing we can do is get out of the way, because things seem to be going pretty well without us. But as database people, I think there are a bunch of things that we can do to make data even more effective in practice. One of them is, how do we actually create tools for these millions of people who want to create, visualize, share, integrate data? Okay. And the other challenge is, so much of this valuable data is just sitting there on the web. How do we build algorithms, tools, crowdsourcing techniques that will enable us to harness all this data into these databases or knowledge bases that we can serve in search and in other applications? Okay, so I'm gonna ask my questions by showing a few of the solutions or partial solutions that we've developed on my team at Google. One of them is what you just saw, Google Fusion Tables, which is the easy-to-use database system in the cloud. Another one is Web Tables, where we went over the web and looked for high-quality data that is just sitting there on the web and waiting to be harnessed. And the third one that is more recent is, how can we, in order to talk about all this data, we need a schema, or some notion of schema. So the third project by Propedia is actually an attempt to mine large-scale schema from the web. Okay, now this is a very small part of the work that is going on at Google in terms of data extraction and data interpretation and all that. So since I only have 45 minutes, there's a whole bunch of other stuff going on, but feel free to ask me later on. So here's another example of Google Fusion Tables. Google Fusion Tables has been around for about 4.5 years now as a Google product. The vision of Fusion Tables was, as we all know as database people, we've created the hardest possible system for humans to use. Okay, so database systems are very powerful, but try using them and you're off to do something else very quickly. But most people who have interesting data and who want to get value out of their data are not database people, and they don't really care about us. They don't care about database people and our nifty techniques. So the idea of Google Fusion Tables was to create a database system that is easy for people to use, people who have data and want to make interesting use of that data. Okay, so here's another example. This is from the New York hurricane. I don't remember which one. But these are the evacuation zones that the local government recommended. So red means you better get the heck out of there unless you like swimming. So this map was created by the local TV station. It was put on a bunch of very popular websites just before the hurricane came. And this kind of map got 100 million page views in those days leading up to the hurricane. Okay, so this is information to people at the right time. We had similar examples after the earthquake in Japan, where we had people putting up maps of where you can find shelters or where there are going to be electrical stoppages. The interesting thing about it was somebody created that map and it got some traffic, and then somebody put it on the homepage of Yahoo Japan. And that's when the traffic spiked. Okay, so in Japan, Yahoo is a big deal. It's a big deal everywhere. Let me emphasize, it's a very, very big deal everywhere. Okay. Did I actually sign that form? This talk can go on YouTube. I'm in deep trouble. Should I say something about Marissa Mayer and how she's making this great company? This is a more recent example of this is from last week. Okay, so somebody was analyzing. This is James Fallows, a very well-known journalist from The Atlantic. They were analyzing all the possible places that the Malaysian airline flight could have landed, and they put it on a fusion table and with a bunch of information about it. Okay, the point here is that James Fallows. I don't want to get into trouble, okay? This is a screenshot. They might be small islands. I don't know. I actually don't know. So let me emphasize the point here. The point is that James Fallows is a journalist. He does not have a team of SQL engineers next to him. But he's got some data. He wants to make it visible to his readers very quickly. So he needs a tool where he can take a CSV file, create a nice visualization, put it on a map, and do this extremely quickly. Okay? And this is exactly what Google Fusion Tables enables them to do. In fact, the journalist community, they use Fusion Tables all the time. They go around giving tutorials about Fusion Tables. So the general point is that if you take a particular very common task that people in the world of data want to do, and you optimize it, okay, you make that flow very easy, then you get a lot of traction. Okay, and one of our benefits here was we had a very deep integration with Google Maps, and so when you bring in a CSV file, we don't even ask you whether what you want to do with it. We see that there's a column with a lat long or a location, and we figure out where those locations are, and you can in 2 clicks see everything on the map. Okay, so that's why it's become popular. Here's one of the best examples of data integration I've ever seen. Okay. This was also created using Fusion Tables. This is right after the Japan earthquake in 2011. So somebody took a data set. These are 2 data sets that were created completely independent of each other. No one ever knew that they're going to be put together. So the heat map that you're seeing is based on a map of all the earthquake activity since 1973. So again, red means unless you really like earthquakes, you probably don't want to live there. Okay. The purple dots, or blue, depending on your point of view, is all the nuclear reactors in the world. Okay, so everybody was asking the question after the Japan earthquake, like, where are other areas in the world where they're very earthquake prone and there's a nuclear reactor nearby? Okay, so this map tells you. Japan. But anyway, you can look at this, you can analyze it later. But this is an example of where putting together two data sources that were built completely independently gives you an answer to a question that is really burning here. Here's another example, but this is an example that is interesting for a different reason. There is these are two counties in New York State. Some journalists went to the county offices, and using the Freedom of Information Act, they got the data with all the addresses of people who asked for gun permits in those two counties. Okay, so this is, according to the Freedom of Information Act, this information is public. Okay, you ask for a gun permit, your name goes into a database that could be public. The thing is, in the old world, that didn't mean anything because nobody's going to do anything with that data. These two journalists got that data and put it on a fusion table. Okay, so now you can actually zoom in to a neighborhood, to your street, and see whether your neighbor has a gun permit. Not even whether they have a gun or not, just whether they have a gun permit. They didn't have to go out and buy a gun. That's secret information, okay? But if they have a gun permit, you would see this. So now, it's not clear that you want that information to be public, right? I don't know that I want to know whether my neighbor has a gun permit. I certainly don't want my neighbors to know that I don't have a gun permit, okay? Right? And so in fact, when these journalists did it, they got harassed. They got harassed by a bunch of people, and and for a while they were asked to take this down. They were saying, "Why are you making this information so visible?" Well, it's public information. Okay, so we have an issue here that what was once considered public information can now be viewed. And so we need to know that if the information is actually public, you may actually see it, which is an awkward question to ask, but you may want to go back. I'm not going to give an opinion about this, certainly not on a talk that's going to go to YouTube, but we may want to go and reconsider some of the decisions about which data should or should not be public. Okay, so we did this. So fusion tables is a nice tool, but it only raises many more questions. One of them is we're very good at creating some simple visualizations. But if you want an interesting challenge, it would be really nice if a system can help you create, with very little effort, a visualization like this. So the New York Times has a very talented team of data visualization people. I apologize. This is the history of meat in the US. So I apologize to vegetarians, and I don't think this slide is kosher either. So multiple apologies. But I'm not asking you to eat it, I'm just asking you to look at it. So wouldn't it be nice if you could actually take a database and automatically create a visualization that shows you the interesting aspects of that data? I'm not saying it'll be completely automatic, that you'll just be able to publish this on the New York Times, but at least it'll give you some hints. It'll make the process of doing this much faster. Today we're good at just putting stuff on maps, putting a nice info bubble on it, and calling it a day. But here, this is the next step of how can we actually take data and make very, very interesting visualizations. I don't know how to do this. That's why I'm hoping one of you does. Data integration as search. So the tool is called Google Fusion Tables. Fusion, okay? So fusion is when I come from data integration, okay? So for me, I don't look only at data, I look at combining data from multiple sources. I'm sort of obsessed with that. As some people here in the audience know that I'm extremely obsessed with that. So how do we make it easy for people to combine data from multiple sources? Because that's when you really start getting value. So what we did in Fusion Tables was we tried to make it a search problem. So you're looking at data from which countries in the world consume most coffee per capita, okay? And you would like to compare this to, you want to add another column here with population of that country. So you should just be able to look at your table and say, put a population into the search box and get a data table that has the populations of different countries and do the join. You don't even have to know that you're doing the join. In fact, you prefer that people not know that they're doing a join, and get the result. So let's make this simple, and this is actually a feature in Fusion Tables today. But this is not so simple, because when you give a tool to people, especially when it's a tool that deals with with data sets, you also introduce the ability to create lies. So here, if you're looking, this is a table with population and murder rates in different cities in the United States. And suppose now I want to join this with another data set that gives me the population or gives me, I don't know, some other aspect of that city. But what does a city really mean? When you say New York, do you mean Manhattan? Do you mean the 5 boroughs? Do you mean the bigger New York area? So these entities that you're joining with, so you might have the population for Manhattan, and then you're going to join it with some other data that includes the 5 boroughs. They both say New York. You think you're doing the right thing. The machine certainly thinks you're doing the right thing. But there's another level at which you're actually doing something very, very wrong. So, this slide shows you that there are multiple definitions of what it means to be a city. Okay? And getting these joins right is not easy. Okay? So we need to help the users to do that. So there's Google Fusion Tables. You can Google it and find it. There's actually a MOOC going on now from Google called Making Sense of Your Data. And they're using Fusion Tables as a way of making sense of your data. I'll move to the next project, which is web tables. So this table is sitting on the web. It's an HTML table. It's a great table. You can answer. Apparently people are looking for the alcohol content of different beers all the time, before they drink or maybe after they drink, I'm not sure. But, so this table actually comes up in search quite a bit. So a few years ago, we started asking, how many tables like this? How many good tables are there on the web? Okay, just good data tables. Not in Fusion Tables, not in any other tools. How many are just sitting there waiting to be searched? And the answer was, one of the nice things at Google, you can actually write a MapReduce. Sorry, we didn't have your fancy tools yet at the time. We didn't actually need them. But you can do a MapReduce and get the answer. And the answer was like 14 billion HTML tables. And just in the core Google index, the main Google index. Okay, this is 4 or 5 years ago. Well, that was fun. 14 billion is, I don't know, several orders of magnitude more than any database system, number of tables that any database system ever had. And as of a couple of years ago, we actually have a special search engine where you can go, this particular search engine, and you can actually search for data tables. The problem is that the vast majority of the HTML tables on the web are actually not very good data tables. So they wouldn't fit what we think of as being a database. Okay, so this is an example where people just had to put stuff in columns and rows, and the only way of doing that in HTML is using an HTML table. So this is the vast majority of the use of HTML tables on the web. In fact, more than 99% of the 14 billion tables on the web are this kind of, I don't want to use any derogatory words, but this is not high quality data. Okay? But there's something very nice about the number 14 billion, which is even after you throw out 99%, you're still left with a really, really big number of tables. Okay? And so we developed a bunch of techniques for filtering these tables and actually finding the good ones. And so the first thing we had to figure out, so this is a machine learning algorithm at the end of the day. There are some simple filters, and then there's a machine learning algorithm that tries to find what are good tables. But some of the problems that arise are, some of the tables are what we call vertical tables. They have, you can think of this as having one column of a table. So the attributes are on the left and the values are on the right. You see them all the time. So in some sense they are a table, but really they're just one row. So if you could put them together, all the rows that are coming from the same sort of schema, okay, put them together in one place, then it would become a very, very useful table. There are other things that make this difficult. So this is a beautiful table. Okay, it's beautiful because, well, it's got a beautiful picture. But this table has very valuable information. Okay, but there's no schema. There on the top there's no schema. As a database guy, no schema. I'm lost. Okay, I don't know how to deal with this. But nobody ever complained to these people that there's no schema because you don't need a schema. This table was designed for people to consume, and they look at this and they understand exactly what it means, and they don't care about a schema. Okay, but if you're looking to put this in a database of databases, then you want some notion of schema. So you need to handle tables that just don't have any schema. Here's another thing. This is a table that was optimized for page layout. So this is a very big table. Okay, so what the designer did here, he or she put it in 2 columns. So this is a station and the postcode, and here's another station, another postcode. So he's putting 2 rows of the database in the same row in the HTML table. Okay, this would also cause a database person to have a major allergic reaction. Okay, but they're not designed for database people. Okay, they're designed for real humans. Okay, and this is optimized in order to so people can look at this and get the value from this. Okay, or here they have here they took this one table and they distributed it across many pages. So you see often that you have a bunch of data and you've got one page for everything that starts with A and another page for everything that starts with B and so on. Fine for people to navigate, very painful for database people. But that's okay, we're used to working in a hard world here. But here's the real thing, okay? So yes? Okay. We can deal with those, we can start dealing with those problems, but the hardest problem is that is that the semantics of the data. Okay, if you want to do anything with this data, you have to understand a little bit of its semantics, because you need to map it to a query. You need to know that this query is asking about this table, and so it doesn't mean you have to have a formal definition of what's in the table, but you have to know a little bit about what is about it. Okay, so a lot of the semantics are not in the table itself. Here you have a table, a beautiful table. You'll see it multiple times in this talk. It's got the coffee consumption per country, per person in every country. And it has a table with a beautiful schema. As a database guy, I'm happy. It says country and it says consumption. What are you consuming? Consuming coffee, you're consuming tea, you're consuming drugs. Okay? So in order to actually bring this table up when people are asking about coffee, I need to understand that this is about coffee consumption. Okay, and not only that, the data can be very brittle. So this is again a beautiful table. Okay, but the main token that is important here is that token 2006. So this is the data from 2006. So there's one little token on the whole page that completely changes the semantics. So if you're asking for the most recent coffee production or coffee consumption numbers, this is the wrong page because there's 2006 there. But nobody tells you that this token is the most important token as far as the time of this data goes. Okay? So HTML tables is just one example that we've worked on a lot on my team. But there are other examples like spreadsheets and CSV files and that thing called XML that Mike Franklin was talking about 15 years ago, but now is just too useful. And so all of these forms of data have very similar challenges. Each one has a little bit of quirks, but I just want to mention that there are all these other sources of data. Let me show you the real problem we have here, okay, when we're going to make use of this data. So we start from the user. Always focus on the user query. Okay, so a user is going to come and say, here is the coffee production, or he or she is going to ask, what is the coffee production of El Salvador in 2013? Okay, now the search engine has several options. Okay, one is to map it to a table. Okay, so there will be a table here with the coffee production of every country that produces coffee. But in order to do that, it needs to know that this table is about coffee production, even though the schema and the data itself has nothing in it that says coffee production. Okay, so this is the problem that I was just talking about. How do we actually understand the tables on the web, what they're really about? Another possibility, so this is sort of a matching of the schema. There's an implicit schema in the user query, right? They're asking for coffee production, and somewhere you're going to understand that this is the coffee production of this. Okay, so all of these schemas are not explicit, but you sort of have to understand that they're there. Another possibility is that the data actually exists in the knowledge graph, the Google knowledge graph. This is the knowledge graph that is showing you Woody Allen and Michelle Obama. So somebody has curated this data and determined that this is very high quality data, and it can be shown. But even in order to figure that out, you need to understand that coffee production in El Salvador will correspond to this path. So countries have exports, and one of the exports of countries is coffee, and coffee is produced every year. And so you need to understand that that path in the graph, in the knowledge graph, corresponds to the answer to the user query. That's a tough problem. Okay? Another possibility is that the answer is actually in text. This is what search engines are very good at doing today, right? It's relatively good. They're good at finding out that this page somewhere contains the answer to your query. So the point of all this is that we have a sort of a new kind of Babel here, where we have a user query which is posed in some schema. Nobody's going to tell the user that what schema to use, and they use whatever words that come to their mind. And we need to map that schema into schemas of tables or of the knowledge graph, or just go into text and find the answer. Okay, so it's a different kind of translation between languages. Now the flip side of that is that we take these data, okay, the data from text, and we take data from tables, and we put that into the knowledge graph. So that's another place where we can take the resources that we have on the web and enrich the knowledge graph that we have underlying the search engine. But this picture to me summarizes the challenges that we have dealing with structured data on the web today. It is to find all of the interesting attributes that entities can have. So we're not only looking for attributes of countries, we're looking for attributes of US presidents and of movies and of films and of hotels. Okay, so we have several thousand classes that we're looking for. So not only do we want to know all the attributes they can have, we also want to know the synonyms. So we want to know that two words actually mean the same thing when people are asking about them. Okay? They may mean the same thing when you're asking about about books, but they may not mean the same thing when you're asking about countries or about US presidents. Not only that, we want to know, actually one of the things that is really important to know is how do people misspell these attributes. So it turns out that people aren't very good at typing. Okay? And so about 15% of the queries that we see, the attributes that we see in the query stream, are mistyped. We want to know that how to correct these mistyping, okay? Because that's going to enable us to answer them. Okay? The other thing we want to know is how do people ask for these attributes? And how do people talk about these attributes in text? Okay, if you're asking what is the age, how old is Barack Obama, in the knowledge graph we don't have an attribute how old. We have an attribute age. But the way you ask about age is you say, one of the ways you say it is how old is X. So we need to know that how old is X means give me the value of age of X. Okay, so how do people ask about attributes? That's a really important way in order to understand how to get to the elements in the knowledge graph. And when somebody writes in text, that Barack Obama is 52 years old, we know that that's an expression of the age attribute of Barack Obama. So it's how do people ask about it and how do people write about it. That's essential in order to really make this ontology useful for search. Okay? So that's the latest effort that we're on to. Anyway, so I'm going to start concluding here. Notice start concluding. I took this trick from Mike. I'm going to start concluding. Okay. Anyway, what I'm trying to say is we have a very significant revolution here, I would say, in terms of, or transformation in terms of structured data in the web. We're using techniques from databases, from AI, from information retrieval. We're combining them in very, very interesting ways in order to produce these knowledge bases that are being used, are being shown hundreds of millions times a day to users. And I think we're just starting. Okay, so now the kind of data that we can analyze, the kind of signals that we have are so extremely promising that we can actually start getting a much higher level of understanding of what are the texts and what are the queries that are being posed to us. Okay, this is geared more towards the younger people in the audience. When the web came about around 1993, and database people were looking at it, we were sort of we we thought we missed the boat, right? We had panels about did we miss the boat? Yeah, we did miss the boat. We in fact, we were not only late, we were late for several boats. But we kept on with our dream that someday structured data would be part of web search, and we had to wait for a while. But dreams do come true. So if you wait long enough and you believe in the importance of some of these ideas in web search, they do come true. And now this is the time for us as structured data people to actually make a contribution to the web. So be patient if you need to. There are a bunch of references that you can go to about some of these projects. A plug for the book about data integration that talks about all kinds of fusion, and you saw many examples of coffee in the talk. That's not accidental. This is because of an even better book that I wrote about coffee a couple of years ago that you're welcome to download from a variety of services. And this is what you should have now. Thank you.